Hello everybody. Today we are going to start chapter 6, the most important chapter of this Foundation 2 class. Let's start from remembering what is GCF. And we have two special cases when we're looking for GCF of two numbers. GCF stands for the greatest common factor. And we have two special cases when we need to find the GCF of two given quantities. The first special case, if we have two numbers, one is smaller, the other is bigger. And if the smaller number happens to be a factor of the bigger number, then the GCF of the two numbers is the smaller number. This actually is not something new. We covered this at the very beginning of the class. This is the first special case. Suppose we have two numbers, two different numbers. One is smaller, the other is bigger. For example, 10 and 30. 10 is smaller than 30. If the smaller number, in this case is 10, happens to be a factor of 30, 10 goes into 33 times, right? 30 is a multiple of 10. Then the GCF of the two numbers is the smaller number, is 10. See if you remember any of this. Oh, actually, oh, okay, no problem. Mark your attendance. Yeah, you say remember this, right? If we have two quantities, one happens to be a factor of the other, then the GCF would be, well, actually, I did not mark Ashley as absent. I did not mark you as absent. Do we happen to have 10 present? We have 11. Did I miss anybody? Dakota, oh, Jacob is here. Let me fix that. Okay. No problem. And another example, if we have two monomials, let's say x cubed and x to the power of 7. We do not have two numbers, but we have two monomials. The two monomials have the same base x. Since x cubed happens to be a factor of x to the power of 7, x to the power of 7 equals x cubed times x to the power of 4th. X cubed is a factor of x to the power of 7. Then the GCF of the two monomials should be x to the power of 3, right? When we have two monomials, actually exponential expressions with the same base, then the GCF would be the one with the lower degree. Do you guys remember that? Let me repeat that, okay? If we have 10 and 30, if we have two different numbers, then of course one is smaller, the other number is bigger. If the smaller number happens to be a factor of the bigger number, and the bigger number happens to be a multiple of the smaller number, then the GCF would be the smaller number. And when it comes to two exponential expressions with the same base, for example, x to the power 3 and x to the power 7, the GCF of those two expressions is the one with the lower degree, because x cubed is a factor of x to the power 7. Okay, very good. You guys remember that. Perfect. Then let's work on some examples here. Let me erase that. Let's see number 2. What's the GCF of 10 and 30? Number 2. What's the GCF of 10 and 30? 10, exactly. Very good. It's special case number 1, right? Perfect. And let's see question number 6. We have two exponential expressions. One is x cubed, the other is x to the power 7. What's the GCF of x cubed and x 7th? X cubed and x 7. Exactly, x cubed. Thank you, Amanda. X cubed. Because x cubed is a factor of x 7th, right? X to the power 7 is 1, 2, 3, 4, 5, 6, 7. And this make a cube, x cubed, and it is a factor of x to the power 7th. And one more. Let's look at the question number 7 right here. In this case, we have two monomials. One is a negative 7x squared. The other is a 14x. How do we find the GCF of those two monomials? The two monomials both have coefficients different from 1, and their variable part have the same base x. Remember, when we have two monomials, we need to find the GCF for them. We go by parts. We find the GCF by parts. We would look at the GCF of the coefficient first. If we have a negative, we'll just ignore it. Okay? 7 and 14. What's the GCF of 7 and 14? Tell me what's the GCF of x cubed, of x squared and x. Exactly, awesome. 7 and 14. 7 is a factor of 14. 14 is twice of 7. That is special case number 1, right? So far, it's been 10 minutes. We are still talking about special case number 1. 7 and 14, GCF is 7. X and x squared, GCF is x, because x has a lower degree. X is a factor of x squared. So combine the two, the GCF of negative 7x squared and 14x is going to be 7x. It's going to be 7x. All right, so that's the first special case. We also have second special case. In that case, the two quantities we are looking GCF for are co-prime. Let me write down second special case. Special case number 2. If the two quantities are co-prime, then their GCF is 1, if you remember. Then their GCF is 1. Okay? Well, let's recall what is a co-prime. Two numbers are co-prime means they have no common factor except 1. The only common factor of the two quantities is 1. When that happens, we say the two quantities are co-prime. If the two quantities are co-prime, then their GCF is going to be 1. 1 is the only common factor, and now make the 1 the biggest common factor, GCF. All right, let's see some examples. Let's say number 3 here. Number 3, we have 4 and 7. How do we find the GCF for 4 and 7? How do we determine if two numbers are co-prime? How do we know? We have learned a technique, if you remember. Big L technique, right? We can put a 4 on top of the big L and then analyze the number. 4 is a 2 by 2. That's the prime factorization of the number 4. And 7 is a prime itself. So we can just write 7 equals 7. And then when we look at the prime factorization of the two numbers, they have no common prime factors. That means they only have one common factor, that is 1. Number 3, question number 3, 4 and 7 are co-prime. So GCF of the two numbers is 1, right? And try number 4, guys. Try number 4. What's the GCF of 5 and 21? What is the GCF of 5 and 21? And you have to know the reason, by the way. Exactly. 5 and 21 are also prime, co-prime. 5 is a prime number. 21 is 3 times 7. And those two numbers have no common prime factors. They only have one common factor, that is 1. So 5 and 21 are co-prime. Since they are co-prime, GCF is 1. GCF is 1. Number 5, 7 and 11. What's the GCF of 7 and 11? 7 is prime, 11 is prime, so they are co-prime. GCF is 1. Exactly, awesome, perfect. And I need to write down the conclusion. You should have this conclusion in your note. We have this covered before. If both two numbers are prime, then they are definitely co-prime. If both two numbers are prime, like the case number 5, like the question number 5, 7 is a prime number, 11 is a prime number, so they are co-prime. Since they are co-prime, GCF is 1. Okay, let's look at number 8. What is the GCF of x and y? Two variables, x and y. What's the GCF of them? What's the GCF of x and y? Exactly, thank you. Very good. X and y are co-prime. All right? So we actually could see x as a monomial, y also as a monomial, and they are both prime monomials. There's no way we can factor x or factor y. So they are co-prime. The GCF is 1. What about number 9? X and 5. GCF is also 1. Perfect. Because they are co-prime. Exactly. We don't use much LCM in this course, but if you go to higher level, for example, pre-cal, I think you probably need to know how to find the LCM for two monomials or even binomials. So here we only care about GCF. in this chapter. Anybody can help me with number 10, the last one? Question number 10, the two given things are both multivariate monomials. We have numbers, we have variables, and not only just one variable, we have three variables. Actually four, xya, xyb. Anyone can give it a try? How do we find the GCF of 21 x squared ya and a negative 28 xy cubed b? It's a lot, looks very busy, but go by parts. Do the coefficient first, and then variable x, and then variable y, and then a and b. 7xy, let me double check. 7xy, correct. That's correct. Very good, very good. Ignore the negative sign, by the way. 21 is 3 times 7. 28 is 4 times 7. Their GCF is 7. X squared and x. X squared and x. GCF is x. Y and y cubed. Take the one with the lower degree. GCF is y. A and B, they are co-prime, so GCF is 1. We do not have to write multiply by 1. The GCF of those two monomials, multivariate monomials, is 7xy. Very good. So now those are warm up. All right, guys, warm up. Warm up for this chapter. The focus of this chapter is to factor polynomials. Firstly, I want to explain what is factoring a polynomial. Factoring a polynomial is to rewrite the polynomial. Factoring a polynomial is to rewrite a polynomial as a product of two or more lower degree prime polynomials. That's the definition of the process of factoring a polynomial. Is to rewrite the polynomial as a multiplication of one or more smaller size polynomials. And those smaller size polynomials have to be prime with lower degree. We don't have to understand this concept right now. We have the whole chapter, to understand this. What is a factor of polynomial? And our focus is to know how do we factor. And we are going to learn multiple methods. And the first method is going to be factoring out the GCF. Okay, we are going to learn multiple methods to factor a polynomial. And the first method we're going to learn is to factor the GCF of all the terms in the polynomial. So let's get started. All right. I'm going to move this part somewhere else. Let's see if I can. I'll just leave some space here. So the first method we are going to learn is to factor out the GCF of all the terms in the polynomial. Knowing this is also the first step whenever we need to factor a polynomial. Okay, let's write this down. Today, the first method we learn to factor a polynomial is to observe the polynomial and identify the GCF of all the terms and then factor out the GCF. And knowing this is also the first step whenever we need to factor a polynomial. So we always have to start from that. All right, let's look at the first question. The first question, the polynomial we are given is a binomial, two terms. The first term is 21x squared ya. The second term is negative 28xy cubed b. We only have two terms. And as I mentioned here, whenever we need to factor a polynomial, we start from looking at the polynomial and identify the GCF of all the terms. If the GCF is 1, then we don't have to do nothing. We can just skip the step. If the GCF is not 1, we have to factor it out. Okay, so let's see what's the GCF of the two terms. The first term is 21x squared ya. The second term is 1928 xy cubed b. What's the GCF of those two terms? 7xy. Same way as earlier, right? Because the previous question is the preparation for this question, number 10 here. 7xy. Very good. So this is how we factor, all right? Once we identify the GCF of the two terms, we are going to copy the GCF, 7xy. Once we identify the GCF of all the terms in the polynomial, we copy the GCF. In this case, it's 7xy. Copy it, and then follow by a parenthesis. Follow by a parenthesis. Follow by a parenthesis. Means we are going to multiply the GCF by a parenthesis. And in the parenthesis, the number, we are going to have exactly the same number of terms with the original given polynomial. The original polynomial is a binomial, two terms. So we are going to also have two terms in the parentheses. And let me show you how do we find the two terms. You might have your own methods from previous math classes, but try my method, especially you are beginner. If you try my method, you can always get it done correctly. All right, so we are going to have two terms in the parentheses. Why? Because the given binomial has two terms. The number of terms gonna remain the same. So in the parentheses, after we factor out the GCF, in the parentheses, we are still going to have two terms. Now let me show you how do we find the two terms. Firstly, we are going to use the original term 1, which is 21x squared ya. Use the original term 1 to over the GCF, we just factored, 7xy. And then plus the original term 2, which is negative 28xy cubed b. Use that to over the GCF of 7xy. I think everybody can do that. Don't rush to do anything yet. Do not rush to simplify yet. This step, all you need to do is to use the original term 1, just to copy exactly what the first term is. Copy exactly the first term and over GCF. GCF is the 7xy we just factored out. And then plus, always use adding. Always use adding. Plus the original second term, which is a negative 28xy cubed b to over the GCF. And then we can simplify the next step. We are going to simplify in the next step. Copy 7xy, and in the parentheses, let's use the quotient rule to simplify the quotient. 21 over 7, as you can see, 21 over 7 is 3. X squared over x is x. Y and y over y cancel. Y over y is 1, so they cancel. And we would have an a in the numerator, so 3xa. That's the simplified form of the first term in the parentheses. And the second term, the second quotient, since the numerator is negative, denominator is positive, we are going to have a negative term. Negative 28 divided by 7 is negative 4. X over x, they cancel. Y cubed over y. Y cubed is y times y times y. And divided by y. So we are going to have 2 y's in the numerator, so y squared. And the b remain in the numerator, remain in the term. And there we go. And that's it. And we're done. We just have learned a very, very important technique. It's called factor out the GCF of all the terms in the polynomial. Let me repeat it. In this question, we have a binomial to factor. We observe the binomial, the two terms in the binomial, and identify the GCF of the two terms. The GCF is 7xy. Once we identify the GCF, we copy the GCF and follow by a parenthesis, or multiplying by a parenthesis. And how do we figure out the content in the parentheses? Everybody can do that. If you follow the steps, all we need to do is to use the original term 1 to over the GCF plus original term 2 to over the GCF. And then you simplify the two quotients, and we are done. As you can see, we rewrote the original binomial as a multiplication of two polynomials. So originally we are given a binomial, right? But now we rewrote the binomial as a monomial times a binomial. The 7xy, the yellow monomial, is prime. And then the blue binomial is also prime because there's nothing we can factor out. So let's look at the definition for factoring a polynomial. Factoring a polynomial is a process. We use the process to rewrite the polynomial as a product, right, of two or more lower degree prime polynomials. So we did it. We rewrote the polynomial as a multiplication of two lower degree polynomials. And let me know, do you have any questions? Does that make any sense? Guys, do you have any questions? No questions? Well, that's good. Yeah, it makes sense. Okay, then please try number 2. Yeah, you do number 2. 14x minus 7x squared. Try number 2. Factor 14x minus 7x squared. This is also a binomial. Seven x times parentheses 2 minus x. Very good. Thank you, Amanda. You are very fast, and that is correct. Okay. So remember the first step whenever we need to factor a polynomial is to find the GCF, right? And the GCF has to be the GCF of all the terms in the polynomial. So we have two terms. The first term is 14x, second term is negative 7x squared, and we go by parts, right? 14 and 7, GCF is 7, x and x squared, GCF is x. The GCF is 7x, so we are going to factor that out from the binomial, and we copy GCF 7x, follow with a parenthesis, and in the parentheses you can repeat the process, the technique that I told you. Use the original term 1 to over the GCF plus the original term 2 to over the GCF. And you simplify in the next step. Copy the GCF of 7x times parentheses. The first quotient, 14x over 7x is 2. Second quotient, negative over positive is negative. 7 cancels 7. X squared over x is x. Very good. So let's see what happened. We rewrote the given polynomial as a multiplication of two lower degree polynomials. Original binomial is 14x minus 7x. We rewrote that binomial as a multiplication of the blue polynomial and the green polynomial. And the blue polynomial is monomial is prime. And the green polynomial is a binomial. It is also prime. 2 minus x, there's nothing we can do to factor that. The original polynomial degree is 2, right? Number 2, the original polynomial degree is 2. 14x minus 7x squared degree is 2. And the blue polynomial is degree 1. The green polynomial degree is 1. So we rewrote the binomial as a product of two lower degree prime polynomials. So that means our factorization is complete. By the way, factoring out GCF is the reverse of distributive property. So the worst case, you should be able to double check your own result to see if it's correct or not. You can do this. 7x times 2 plus 7x times negative x to see if you have the original binomial. 7x times 2 is 14x. 7x times negative x is negative 7x squared. So if you go back to the original given binomial, that means your factorization is correct. And then double check, make sure each polynomial in the multiplication are prime, then your factorization is complete. We need not only the factorization to be correct, we also need a factorization to be complete. Means that you are through. You cannot go further. The factorization cannot go further. Same with number 1 earlier. We can double check by multiply the yellow monomial with each term in the blue binomial to see if we have the original given binomial. All right. Any questions so far? If you are able to factor number 2, then you are good. You are good. Perfect. Thank you, Jill. And try number 3, please. Number 3, we are given a trinomial. 14x minus 7x squared minus 1. We need to factor this trinomial. Remember, what's the first thing to do when we need to factor a polynomial? Identify the GCF, right? And let me know what you have. What's the GCF? That looks like question number 2. So let's think about the 3 terms in the trinomial. So we have 14x as the first term, negative 7x squared as the second term, and negative 1 as the third term. Think about what's the GCF of the 3 terms. What is the GCF of the 3 terms? One. Thank you, Ashley. Yeah, exactly. Hope you see that. The 3 terms, the GCF of all the 3 terms is 1. Right, guys? Look at the difference between question number 2 and question number 3. The first 2 terms are the same. I add one more term, like a negative 1, and that makes a huge difference. Let's read the rule. Here we says the first step whenever we need to factor a polynomial is to identify the GCF of all the terms in the polynomial. When we have a trinomial, we have 3 terms. Then if we need to factor the GCF out, the GCF has to be the GCF of all the 3 terms. And when we write down the 3 terms, you will see the GCF of the 3 terms is just 1. Right? Okay, perfect. So if the GCF is 1, we do not need to factor anything out. We do not need to factor anything out, okay? Just skip the step. We just need to skip the step. So let me emphasize. The first step, whenever we need to factor a polynomial, is to identify and factor out the GCF of all the terms in the polynomial. In the case the GCF of all the terms is 1, we skip the step. We do not really factor 1 out. All right, guys? Then that's the first, that's number 11. The first technique we learned about factoring a polynomial. And question number 12, 12 on my worksheet. What is factoring a polynomial? Compare the process with the process of prime factoring number. The two processes so close. So I'm gonna write both process and we compare. Prime factor a number is to write the number as the product of all its prime factors. And we are going to compare this with this. One I wrote in blue, the other is in black, right? The blue paragraph describes the process of factoring a polynomial. The black paragraph describes the process of factoring, prime factor a number, prime factor number. So compare the two processes. Try to see the similarities between the two processes. They both are actually rewrite the given stuff as a multiplication, right? When it comes to factor a polynomial, it is to rewrite the polynomial as a multiplication of 2 or more lower degree prime polynomials. And very similar with prime factor number. Prime factor number is to write the number as the product of all its prime factors. For example, 36 equal to 2 times 2 times 3 times 3. That is a prime factor number. And the two processes are very similar. I hope compare the two processes can help you to remember and understand what is factoring a polynomial. What is the process of factoring a polynomial? Next, we are going to learn the second method of factoring a polynomial. Let me write it down. Method number 2. Second technique of factoring a polynomial is called factoring by grouping. Focus on understanding the following a few things. When do we use this method, factoring by grouping? And how do we use this method? So when do we apply factoring by grouping? When we have a polynomial containing 4 terms. Please write it down. The second technique we are going to learn is called factoring by grouping. And we only apply this technique to factor polynomials with 4 terms. If it has 2 terms or 3 terms or 5 terms, we do not apply this method. We only apply this method when we need to factor a polynomial with 4 terms. For example, here, number 3, x cubed minus 4x squared plus 3x minus 12. This polynomial has 4 terms, right? And we would consider use this technique, factoring by grouping. Or number 2, ab minus 7a plus 5b minus 35, 1, 2, 3, 4, also 4 terms. So we should consider use factoring by grouping. Same with this one. I explained when do we apply this technique, right? To prepare of understanding this technique, let's look at the first question first. X times parentheses x minus 5 minus 7 times parentheses x minus 5. So we are given an expression. Let's look at the structure of this expression. Let's look at the structure of this expression. I would see this expression has as the addition of two parts. I would see this expression, the structure of the expression, as an addition of 2 parts. The green part and the blue part. And we're adding them together, okay? Blue plus green. That's the structure, blue plus green. Okay, question. Look at the, green. Did I say that? Sorry, green plus blue. The green part is x times x minus 5. The blue part is -7 times x minus 5. I have a question. Look at the 2 parts. Do they have anything in common? The green part and the blue part. It's the green part and the blue part. Do they have anything in common? The green part is x times x minus 5. The blue part is -7 times x minus 5. X minus 5, perfect. Exactly. Exactly. We say the 2 parts, they have common binomial factor. In this case, x minus 5. X minus 5 is a binomial, right? X minus 5 is a binomial. And It is a factor of the green. The green expression, the green part has two factors. X is the first factor. X minus 5 is the second factor. It's a multiplication. The blue part also has two parts multiplied together. The first part is -7. The first factor is -7. The second factor is x minus 5. They both have x minus 5 as a factor. So x minus 5 here is a common binomial factor. Very good. Since the two parts have x minus 5 as the common binomial factor, we are able to factor x minus 5 out. Remember, how do we factor something out? We copy it and then follow with a parenthesis. Copy x minus 5 and then follow with a parenthesis. Let's see, how do we do that? The first part, the green part, we factor this part. We factor x minus 5 out. We factor x minus 5 out. Like we kick it out. And what's the leftover factor? We move x minus 5 outside this parenthesis, the second parenthesis. And what's the leftover factor from the green part? Very good. And then is x. Perfect, is x. And then look at the blue part. We factor x minus 5 out. We kick it out. And what's the leftover factor from the blue? -7. Perfect, -7, exactly, not +7. So -7. -7. And done. We finished. Once we factor the common binomial factor, x minus 5, and from the green part, we have leftover x. From the blue part, we have leftover -7, and put them together in the parentheses. And we successfully rewrote the given expression as a multiplication of two prime binomials. I think I'd like to introduce this here. X plus a number, a variable plus a number, is always prime. If you see a if you see a binomial whose structure is a variable plus a constant, then that binomial definitely is prime. X minus 5 is prime because this binomial has a structure, a variable plus a number. X is the variable, 95 is the number. So x minus 5 is a prime. Same with x minus 7. X is the variable, 97 is the constant. So x minus 7 is a prime. We rewrote the given expression as a multiplication of two prime binomials. So we just factored the given expressions. And let me know, am I clear about this question? Am I clear about how do we get x minus 7 in the parentheses? Factor out means we kick it outside the parentheses. Okay, I got a positive feedback, but don't worry about that. If you are not understanding and you want to ask the question, I don't think you should feel afraid of asking questions. I appreciate if you let me know it's not clear. I don't understand. I'm not seeing it. I'll explain again. Okay, very good. As I mentioned, the first question is to prepare us for applying the factoring by grouping method. Now we are ready. I think I'm going to go to work on number 3 first. Now let's factor the polynomial in question number 3. We have x cubed minus 4x squared plus 3x minus 12. Our task here is to factor this polynomial. This polynomial has 1, 2, 3, 4 terms. Well, if you need to factor a polynomial with 4 terms, you need to think about this method. You need to know the name of the method, factoring by grouping. Why do we need to apply factoring by grouping? Because 4 terms, we see 4 terms a lot. If you have a lot of small things, and how do you organize those things? You want to group them, right? This part as those as the first group and put them in this drawer, and this together as the second group, put it in the second drawer, right? You want to divide them into groups. If you have too many things, you want to divide them into groups. Same with here. When you have 4 terms in the polynomial, we see that as a lot. We're going to group them. How do we group them? I can say pretty sure that in this class, you could always group the first 2 together and then group the last 2 together. It should always work. If not, let me know. I think all the questions we see should work. So I'm going to use 2 different colors, right? I'm going to use that is green, is blue. So I'm going to write this is a blue, right? This is blue. Oh, this is blue. Okay. So the first 2 terms as blue group, and the plus, and the last 2 terms as green group. Excuse me, minus 12. All right, this is how do we group first 2 terms and the last 2 terms. Or you can think about this, cut in half, 4 terms, right? Cut in the middle, and the first 2 terms group 1, second 2 terms, the last 2 terms group 2. Be careful with the sign. And in our case, we have 2 groups colored in different colors, blue and green. And I'm going to use 2 boxes to organize the 2 groups, okay? And then we put them back. This is the blue box, this is the green box. In the blue box, we're going to process the blue group. We have x cubed minus 4x squared. In the green box, we're going to process the green group, 3x minus 12. Okay, let's do that. The blue box, x cubed minus 4x squared, we have 2 terms. We want to factor out the GCF of them. Anyone can help me to identify the GCF of the 2 terms in the blue box? X cubed, negative 4x squared. What's the GCF of them? One x squared, exactly. Or just x squared. Perfect. Very good. Thank you, Amanda. Awesome. Let me factor x squared out. We learned this earlier, right? Factor x squared out and then times parentheses. Who would help me to figure out what's in the parentheses? Well, the technique I teach earlier. Use the original term 1 to over the GCF plus original term 2 to over the GCF. And then you're going to simplify in the next step. X cubed over x squared, x, negative 4x squared over x squared, minus 4. Do you have the same thing, guys? You know, if you are not sure, what do? You can reverse the process, right? X squared times x, x cubed. X squared times negative 4, negative 4x squared. So far, so good? That's what we do for the blue group in the box. And we're going to do the same thing to the green box. In the green box, we also have 2 terms, 3x and negative 12. Please help me to find the GCF of them. 3x and negative 12. 3x, yeah. It's 3. Very good. It's 3. Perfect. It is 3. So we're gonna factor 3 out and follow with a parentheses. And this time I want you to help me to find the stuff or content in the parentheses. Use my technique. Original term 1 over the GCF plus the original term 2 over GCF. And let me know what you have in the parentheses. X minus 4. Very good. Perfect. We have 3x. Original term 1 over GCF. Original term 2 over GCF. And we keep 3 here. 3x over 3x. Then 12 over 3 minus 4. Okay? You see that? Yeah. Correct, Kaylin. It is x minus 4. It is x minus 4. If you are not sure, what do? You double check by reverse, right? Remember I told you factoring out GCF is the reverse of distributive property. So we can double check our result by applying the distributive property. 3 times x, 3x. 3 times negative 4, negative 12. Very good. Now let's put them back. I want a black now. Oh, hold on. I want a blue. So the first part, the blue group right now is x squared times x minus 4 plus the second group is 3 times x minus 4. Look at here. Look at the yellow part from the two groups. Are they the same? They are the same, right? You know, we want them the same. In the blue box, we have x minus 4 in the parentheses. So in the green box, we're supposed to target or expect or figure out a way to make the parentheses, the leftover in the parentheses to be the same, x minus 4, whatever you need to factor out. Okay, let me repeat what I'm trying to say is, our goal here is, from both boxes, both groups, we want to factor something out such that in the parentheses, we have exactly the same thing. And they have to be prime, by the way. Okay, they are the same, means we have the two groups have common binomial factor x minus 4. It's the same with earlier, right? Same with this question we did earlier, question number 1. So let's factor the common binomial factor, which is x minus 4, left over from blue group. The yellow is out, and the leftover would be x squared, right? And from the second group, the yellow is out, the leftover is 3. And we're done. Look at the original given polynomial. It has 4 terms, and the degree is 3. We rewrote that polynomial as a multiplication of 2 polynomials. And this one has degree 1, and x squared plus 3 has degree 2. They both have a lower degree, and they are both prime. X minus 4 is prime, x squared plus 3 is also prime. And let me know, does that make sense? This is a factoring by grouping. And you try to ask yourself 2 questions. When do we use factoring by grouping? And how do we apply factoring by grouping? We use this technique we need to factor a polynomial with 4 terms, right? And how do we do it? From the middle of the 4 terms, cut it in half, and then, group them into 2 categories or 2 classes. The first 2 terms as the first group, the last 2 terms as the second group, and then fetch out the GCF from each group and try to make the leftover in the parentheses the same, and then fetch out the common binomial factor, and we are done. So that's the technique of factoring by grouping. Very good, perfect. And do you guys want to try one? You want to try number 2? Number 2 just have 2 variables. It has 2 variables, A and B. Give it a try. I'll give you 2 or 3 minutes. It has 4 terms, right? Doesn't matter how many variables. It has 1, 2, 3, 4 terms. Do the exactly same thing. Cut it in half, right? And this is you can use your colors. I would use, this is the blue group, this is the green group. Give you 2 or 3 minutes. That's correct. The first group, GCF is A. Very good. B minus 7, I think it's correct. Good job, Joe. Perfect. Very good, very good. And pretty quickly, you guys get it done pretty quickly. Well, let's look at this problem. Let me find a space. I run out of space. Let me do that here. Number 2, the polynomial is AB. Let me copy paste. Copy paste. I'll work here. So we're gonna have AB minus 7A as the first group, 5B minus 35 as the second group. From the first group, AB minus 7A, GCF is A. Factor A out, we have B minus 7 in the parentheses. If we are not sure, we double check by reversing using distributive property. A times B, AB. A times 97, 97A. And that's the first group. Second group, 5B minus 35, GCF is 5. We want what we want in the parentheses, knowing we want B minus 7, okay? We want B minus 7. Let's see if it works. 5 times B, 5B. 5 times 97, 35. It works. If it doesn't, you want to modify a little bit. something need to be modified. Make sure you have the same thing in the parentheses. Now the two groups have b minus 7 as a common binomial factor. We can factor b minus 7, and from the first group we have left over a, from the second group we have left over 5, and the result is b minus 7 times a plus 5. You guys are doing great, very good. Then please try number 4. Please try number 4 here. 2ax plus 6bx minus ay minus 3by. Just have a bunch of too many variables. But the method is the same. The way to process is the same. Cut it in half, like that. But knowing that this is going to be negative, okay? Do not omit that negative sign. Don't forget the negative sign. Give you a couple minutes. I think it's correct, Amanda. I worked on this one thinking it was number 2. Oh, okay. Okay, you can work on number 2 now. Very good. Well, let's see how do we process this polynomial. First group, 2ax plus 6bx. Second group, negative, knowing is negative, negative ay minus 3by. From the first group, the two terms, we factor out GCF. 2 and 6, GCF is 2. X is common, right? Factor 2x out, we have a plus 3b. If we are not sure, what do we do? Double check by reversing. 2x times a, 2ax. 2x times 3b, 6xb or 6bx. Very good. And the second group, they are both negative, right? The two terms in the second group, they are both negative. Knowing you are going to factor a something negative, such that in a parentheses, you have the same thing. The goal is to factor in a GCF or negative GCF such that the binomial in the parentheses is the same thing. So obviously, we need to factor out negative y to reach that goal. Double check, negative y times a, negative ay, negative y times 3b, negative 3by. And they do have the same binomial factor, a plus 3b. So we factor a plus 3b. From the first group, we have 2x left. And from the second group, we have negative y left. By the way, guys, if you use the box method to multiply this out, you should have the original given polynomial. So you can double check by multiplying the two binomials, and you should have the original polynomial. If not, it means something went wrong. You have to fix it. All right, guys. Are we good with the second technique we learned to factor a polynomial? Answer the two questions in your head. This technique is called factoring by grouping. Factoring by grouping. And when do we use it? And how do we use it? When do we use factoring by grouping? And how do we use? To answer how do you use, at least you need to have a process, like impression. What should I do first, and then what do we do next? At least you have that. Thank you, Jill. We use that technique when we need to factor polynomial with 4 terms. Cut in half, yeah, cut in half. That first group and the second group, right? And factor out GCF. We want they have the same left over in the parentheses. And then we factor out the common binomial factor. Very good. I think if you understand, you understand. If not, you're welcome to email me if you don't want to ask in the class. You can just ask me through email, you know, knowing I'm available to you for you. Okay, do not hesitate to reach out. So far so good. Okay, sounds very good. Well then, so far we have learned 2 techniques. The first technique is to identify and factor out GCF of all the terms in the polynomial. And then that's also the first step whenever we need to factor polynomial. I have a question. How come we did not use that first step when we do the factoring by grouping? We did not go through, identify the GCF of all the 4 terms and factor it out. Why didn't we do that? Yeah, since I wrote here, factoring out GCF is also the first step whenever we need to factor a polynomial, right? How come we didn't do that here? We did not do that for number 2, number 3, number 4. What's the reason? The reason is because the GCF of the 4 terms is 1. So we skip it. Okay? The reason is because the 4 terms, the questions that we have, the polynomial has 4 terms, and all the 4 terms, the GCF of the 4 terms is 1. There's nothing to factor out. That's why we skip that step. In the case the 4 terms do have a GCF different from 1, we would have to factor out the GCF. But I don't think you would have that question. Okay? Yeah. The real reason we did not do that, we skipped the GCF part, is because the GCF of all the 4 terms is 1. As you can see, AB, 97A, 5B, 35, GCF of all the 4 terms is 1. Same with number 3, x cubed, 94x squared, 3x, 12. The GCF of all the 4 terms is 1. So that's why we skip that step. Okay, perfect. All right, so let's move on. We're going to learn the next technique, okay? The next technique is called the shortcut method. We're going to take time. This is going to be a big project. Shortcut method. We're going to take a while to really understand this technique. So we do not rush. We're going to take our time, okay? We're going to take our time to learn this very, very, very important technique. Firstly, we want to know what is a quadratic trinomials. Firstly, we need to know what is a quadratic trinomial. What is a quadratic trinomial? Quadratic in algebra means degree 2. This might be a little bit different from what we say someone has the quads, 4-wheel that they can drive on the dirt road. It's called they call them quads. Quad seems like a 4, right? Quadrilateral, quadruple, but quadratic here, for some reason, it means degree 2. So please do not understand quadratic means degree 4. No, make it simple. We do not go that high. We go 2, at most 2. So quadratic in algebra means degree 2. Trinomial, we understand. Trinomial means 3 terms, right? And what does quadratic trinomial look like? It looks like this. ax squared plus bx plus c. That is the standard form of a quadratic trinomial. Any polynomial which can be written in that form is a quadratic trinomial. And it is a trinomial 1, 2, 3, right? And the trinomial is in a standard form. The first term, leading term, is the x squared term. The middle term is the x term. The last term is the constant term. A, B, C are constants. A here is the leading term. Sorry, leading coefficient. A is leading coefficient. And B here is the coefficient of the middle term. I call this as middle term because it's right in the middle, right? And C is the constant. And leading coefficient has to be non-zero. Otherwise, we do not have a quadratic trinomial. But you don't have to worry about that. It's always non-zero. So if we have a polynomial look like that, x squared, ax squared plus bx plus c, you see the degrees go down to 1, 0, right? And that polynomial is a quadratic trinomial. And this is the standard form. This is the standard form. This is the standard form of a quadratic trinomial. So we need to know what does a quadratic trinomial look like. And we also need to know what's the standard form look like. If the trinomial is not in the standard form, we would have to write the quadratic trinomial in a standard form. Okay? And the shortcut method. When do we use this method? We use it to factor a quadratic trinomial with a leading coefficient 1. Let me write it down. We use shortcut technique or method to factor quadratic trinomials with leading coefficient equals 1. Like a here is 1. And you might wonder, what if a is not equal to 1? Then we have a different technique. We're going to learn that technique later, probably not today. So shortcut method, we apply this method when we need to factor a quadratic trinomial with the leading coefficient equals 1. Okay, let's see some of the examples. Number 1, x squared minus 7x minus 8. Here I want you to help me to determine if they are quadratic trinomial. So here I want you to help me to determine, are they quadratic trinomial? If they are, what is A, what is B, what is C? That's the practice, okay? Yeah, I just gave you the definition of a quadratic trinomial, and let's practice. Number 1, x squared minus 7x minus 8, we are here. X squared minus 7x minus 8. Is that a quadratic trinomial in a standard form? If it is, can you help me to identify A, B, C, the values of A, B, C? Yes, it is. By the way, the A, B, C are gonna be numbers, not terms. Numbers. A is the coefficient of x squared. B is the coefficient of x. C is the constant term. So if I write the polynomial right below this, x squared minus 7x minus 8. Again, A, B, C have to be all constants, numbers. Do not include x. What is A? 1. Perfect. B is 97. C is negative 8. Awesome. Very good. Perfect. Thank you, Amanda. A is 1. B is 97. C is negative 8. Perfect. This is a quadratic trinomial with a leading coefficient 1. A equals 1, right? Okay, try again. Number 2. Determine if that is a quadratic trinomial. If it is, what is A, what is B, what is C? I'm going to practice that. Question number 2, x squared plus 5x plus 6. Is that a quadratic trinomial? If yes, what is A, what is B, what is C? Perfect. Perfect. Very good. A is 1. Yeah, again, A is the leading coefficient or the coefficient of x squared, the number in front of x squared. And B is the coefficient of x. C is the constant. Perfect. Next, x squared plus 7x minus 8. Determine if it is a quadratic trinomial. If it is, what's A, what's B, what's C? Very good. You guys great. That's A is 1, B is 7, C is negative 8. Number 4. Determine if the given polynomial a quadratic trinomial. Quadratic again means degree 2. If it is, and what's A, what's B, what's C? You would have to make sure the trinomial is in the standard form, and then you identify ABC. 1, negative 13, 36. Perfect. Number 5, x squared plus x plus 2. 112. 112. Awesome. Very good. 112. Number 6, determine if that is a quadratic trinomial. If it is, what is A, what is B, what is C? Perfect. Perfect. 1, 91, 91. Number 7. Number 7. Identify if number 7 a quadratic trinomial. If yes, what is A, what is B, what is C? Be careful the sign, okay? Number 7. 91, 95, 96. That's correct. And number 8. Determine if that is a quadratic trinomial. If yes, let me write a formula again here. We call this a formula, okay? Ax squared plus bx plus c. That's the standard form of a quadratic trinomial. What's A, what is B, what is C? 3, 90, 27, 42. Perfect. Very good. 3, 90, 27. Be careful with the sign. The coefficient of x is negative, so please do not forget the negative sign. And positive 42. Very good. Number 9, is this polynomial a quadratic trinomial? If yes, what is A, what is B, what is C? 92, 90, 16, positive 30. Negative 30. Is negative 30, right? Yeah, be careful. So 92, negative 16, negative 30. Very good. Okay, that's it. Can we all answer the question? I mean, are we all good with what is a quadratic trinomial and how do we identify the values for A, B, and C in a quadratic trinomial? Are we good with that? I think Amanda is good, Joe is good, Dakota is good, Ashley is good. I don't know other. I hope you're good, okay? If you really feel, do not hesitate to reach out if you have any questions. Perfect. And we are still preparing to really before I really introduce what is the shortcut method. We're still preparing for that, okay? Now, as part of the preparation, we need to understand the following 4 conclusions, okay? 1, 2, 3, 4. Understand that. Let's see what are the 4 conclusions. Number 1, if 2 integers multiply to positive and add up to positive, then the 2 integers must be both positive. That's the first conclusion. Let's make sense of it. If we need to determine the signs for 2 integers, and we know the 2 integers multiply to a positive number, also add up to a positive number, then the 2 integers must be both positive. Think about why. Let me explain. Firstly, the 2 numbers have to be both integers. Integers are 1, 2, 3, 4, and so on, and 91, 92, 93, 94, and so on, and we're 0, right? So here we don't really use 0. So it's either positive integers or negative integers. So 2 non-zero integers, if we know they multiply to positive, think about if we know 2 numbers multiply to positive, the 2 numbers must have the same signs, right? Did I pronounce this correct? They must have the same signs. Yeah. They either are both positive or both negative in order for them to multiply to a positive number, right? Because if the 2 numbers have an opposite sign, their multiplication is supposed to be negative. Do you agree? If 2 numbers multiply to positive, the 2 numbers must have the same signs. And since the 2 integers add up to positive, the 2 numbers have to be both positive. Because if they are both negative, think about if they are both negative, there are 2 negative integers. What's going to be their addition? Their sum must be a negative integer, right? Do you agree? Yeah, let's try to make sense of the first conclusion. Make sense means you really understand, you agree. If 2 integers multiply to positive and add up to positive as well, then they must be both positive. They must be both positive. Do you agree? They cannot be both negative because 2 negative numbers are not possible to add up to a positive number. For example, -1 minus 3. If we add up 2 negative numbers, we must have a negative number. Means both games you lost money. You lost money for both games. You are not gonna end up with winning, right? You're gonna just lose more. Okay, thank you, Joe. And that's the first conclusion. Let's see the second conclusion. Second conclusion, if 2 integers, this time forget about number 1, okay? The 4 conclusions are separate. Suppose, now the conditions have changed. Suppose the 2 integers multiply to positive, but this time they add up to negative. So basically we have 4 cases. This is case 1, we got Done. Now we are talking about case 2. In case 2, we need to find the two integers. What do we know about the two integers? We know that they multiply to positive, but they add up to negative. Now, how do we determine the signs for the two integers? Since they multiply to positive, they must have the same sign. Because they multiply to positive. Again, if they have an opposite sign, they're going to multiply to a negative number. The reason they multiply to positive is because the two numbers are both they both have the same sign. They either both positive or they both negative. But they cannot be both positive because the addition has to be negative. So the two numbers are both negative. Because if they are both positive, their addition must be positive. But no, the integers we are looking for, they add up to negative. So the two integers have to be both negative. And let me know, is that clear? If two integers multiply to positive, if they have the same sign, they are either both positive or both negative. Since they add up to negative, they have to be both negative. As mod. Yeah. Let me think. How about this? Let me make a table. Thinking about multiplication, okay? Multiplication. Like A times B. Think about A times B. A times B. This is A, this is B. We think about two numbers. If the two numbers, they have opposite sign. So if this is a negative, this is a positive, they multiply to negative. If this is negative, this is positive. No, hold on, my bad. This, I want to do this. So if both the two numbers are positive, they multiply to positive. If one is positive, the other is negative, they multiply to negative. Same as here, if one positive, the other is negative, they multiply to negative. If they are both negative, they multiply to positive. Okay, so or I can give you two specific numbers. How about I give you specific numbers? Let's talk about 2 and 3. 2 and 3, they're both positive, right? So they multiply to positive. If we have two numbers, they are both negative. For example, 92, 93, they multiply to positive. But if the two numbers, one is positive, one is negative, for example, 92 times 3 or 2 times 93, they will give us -6. So firstly, we need to understand when it comes to multiplication, if the two numbers have the same signs, either both positive or both negative, then they multiply to a positive number. If they have an opposite sign, like these two cases, one is positive, the other is negative, then their multiplication must be a negative number. That should be clear, right? Yeah, that should be clear. So look at the case 1. If the two integers multiply to positive, add up to positive, then they must be positive because since they multiply to positive, they either are both positive or they both negative. So let me write down here. They both positive or both negative, but they cannot be both negative. They cannot be both negative because If they are both negative, they are not going to add up to a positive number. So they have to be both positive. And case 2, we know that we are given, we know the two integers multiply to positive, add up to negative. So the two numbers must have the same sign, right? So either both positive or both negative, but they cannot be both positive because they add up to a negative number. So the two numbers have to be both negative. It's using logic here, actually. But kind of confusing when I say positive, negative so many times. Number 3, case 3. Case 3, the condition changed, okay? So in this case, the two numbers, they multiply to negative. They multiply to negative. And then they add up to positive. Okay? Case 3, the two integers multiply to negative and they add up to positive. So they multiply to negative and add up to positive. Let's try to make sense of the conclusion. If the two integers multiply to negative but add up to positive, then the two integers have an opposite sign. Opposite sign. One is positive, the other is negative, right? Because their multiplication is negative, so they must have an opposite sign. And since they add up to positive, that means the positive number has a bigger absolute value. For example, 97 and the positive 3. Those two numbers have an opposite sign, right? So if you multiply them together, you get a negative number. But the negative number has a bigger absolute value, so if you add them up, you're going to have a negative number, right? It's like the two games. The first game you lost $7, the second game you win $3. But since the first game you lose more than the second game you earn, you end up with a negative. So it's not this case. It's not this case. It has to be the case in which the positive number is bigger, has bigger absolute value. If the two integers multiply to negative and add up to positive, means the two integers have opposite sign. You at least need to understand that. You have to agree on that. If the two integers multiply to negative, means they have opposite sign, right? Okay, listen guys, do you agree that if the two integers, if the two integers multiply to negative number, they must have an opposite sign. One is positive, the other is negative, right? Okay, thank you. So we try to think the first number is the profit of the first game, second number is the profit of the second game. Since the addition, their sum is positive, means the guy end up with winning. That means the first game, when he wins, he win more than he lost. So that's why we know the positive number is going to have a bigger absolute value than the negative number. Use the casino method. Do you think it is easier to understand that? If two integers multiply to negative, add up to positive, they have an opposite sign. One is positive, the other is negative, and the positive integer has a bigger absolute value. You can understand like the first integer describes the profit of the first game. The second integer describes the profit of the second game. Since the guy end up with winning, and we know one game is losing, the other game is winning, but he end up with winning. That means the winning game he win more than he lose, right? So the positive number has a bigger absolute value than the negative number. And let me know, is that a little bit understandable? Okay, perfect. And case number 4. In this case, the two integers multiply to negative, add up to negative as well. So what conclusions we can draw from that? So since they multiply to negative, you're gonna agree with me. Since they multiply to negative, they must have opposite sign. Okay? So one game winning, the other game losing. Because the multiplication is negative, they must have opposite sign. But the addition of the two integers is negative, means one game is losing, the other game is winning, and he end up with losing. That he must lose more money than he winning, right? So it would cannot be this case, has to be this case. The losing game, he lose more than he win. So that's the case number 4. If two integers multiply to negative, they have opposite sign. One is positive, the other is negative. And they add up to negative. Since they add up to negative, the negative number has bigger absolute value. The game he lose has more. He lose more than the game he wins. That's why he end up with losing. Does that make sense, guys? I would recommend a little better. Perfect. Much better. Okay, makes sense. Awesome. Perfect. Yeah, try to think about the casino method. Like the first integer is the profit of the first game, second integer is the profit of the second game, right? That would help you to understand. I believe my experience, the casino method always work. Those 4 conclusions, super important, very important. Okay, is a very critical component of this method. What's this method? It's called a shortcut method. Shortcut method here. Okay, now we are ready. Now we are ready to use the shortcut method to factor polynomials. Okay, question. When do we use the shortcut method? I have this written here. We use shortcut method to factor quadratic trinomials with leading coefficient 1. Has to be a quadratic trinomial. 3 terms, degree is 2, and the leading coefficient has to be 1. And then you think about shortcut method. All right, let's see number 1, question number 1. We did this already, right, earlier? X squared minus 7x minus 8. It is a quadratic trinomial with the leading coefficient 1. Because a is 1 here, right? A is 1 here. So means the shortcut method is going to apply. Let me show you how do we apply the shortcut method to factor it. Okay. We go ahead. Once we know this is a quadratic trinomial with leading coefficient 1, we go ahead to find two integers, multiply to c, and add up to b. You need to memorize this process or the step, critical step, and you should include that in your note. For shortcut method, once we know the trinomial is a quadratic with leading coefficient 1, we go straight to find two integers whose product is c and whose sum is b. Find two integers whose product is c and whose sum is b. We know what is c, what is b, right? In this case, c is negative 8. Let me write up here. C is negative 8. B is negative 7. So in this case, we are looking for two integers. They multiply to negative 8 which is the value of C, and add up to -7, which is the value of B. So we are looking for two integers, multiply to negative, add up to negative. Which case this is? Earlier we got 4 cases. Which case this is? We are looking for two integers, multiply to negative, also add up to negative. Add up to negative. Let's look at it again. We are looking for two integers, they multiply to number 4. We're looking for two integers, they multiply to negative and add up to negative. Multiply to negative, add up to negative. Case number 4, right? Yeah, right, okay. What is the word? Okay. They add up to, they multiply to negative, add up to negative. My puppy, your puppy wrote it? Okay. Okay. The Ashley says 92 and 4. They have to add up to 97, by the way. Well, I'm very slow. I want to make sure every small part is clear, but sometimes you might lost in the middle. Okay, so this is case number 4. They add up to positive, multiply to positive, so they have opposite sign. One is positive, the other is negative. Also, the negative number has a bigger absolute value. The negative number has a bigger absolute value. The positive number has a smaller absolute value. Do we agree on that? Conclusion number 4, or case number 4. They multiply to negative, add up to negative. They have an opposite sign. One is positive, the other is negative, and the negative number has a bigger absolute value. Means the losing game, he lost more money than the winning game. And which two numbers? This is what we do. We are going to factor absolute value of C. In this case, absolute value of C is 8. How do we factor it? Once I show you the pattern, you understand. We always start from 1. 1 times 8. Try 2. 2 times 4. Try 3. 3 doesn't work. Try 4. 4 is already there. 5. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8. 8 is already here, right? So we only have 2 ways to factor 8. Write 8 as multiplication of two numbers. And then since, you know, those 2 columns, let me show you colors, okay? The first column is blue. Second column is purple. As you can see, the purple column for each pair, the purple column has a bigger absolute value than the blue. Since we agree the negative number has a bigger absolute value, so we're going to place a negative sign here, a positive sign here. The two integers we are looking for have an opposite sign. One positive, the other is negative. Since in this case the negative number has a bigger absolute value, so that we put a negative sign on top of the pink, positive sign on the top of the blue. And let's try. First case, positive 1, negative 8. Do they add up to 97? And second case, positive 2, negative 4. Do they add up to 97? No, right? But positive 1, negative 8 add up to 97. So the two integers are positive 1, negative 8. And once we found the two integers, we are able to factor the trinomial directly as this. Parentheses times parentheses. In the first parentheses, we have x plus a number. In the second parentheses, we have x plus another number. And which two numbers? The two numbers we just found. Positive 1, negative 8. Done. I know we run out of time. It's okay you feel I'm not getting it. That's totally normal. Because we are going to repeat the process over and over and again throughout the whole chapter. Hope at a certain point you understand, and you know how to apply on your own. So we're gonna have to stop here and continue on Wednesday and practice more, and I'll show you how we apply shortcut method many times more times, many more times, so you will understand. Okay guys, I will see you on Wednesday. Have a good night. Bye bye.